Professor Wyman. My name is Jada Branch, and today I'll be discussing intramembranous ossification. Okay, what exactly is intramembranous ossification? It is a process that involves bone development in our bodies, and it's also called dermal ossification because it occurs in the dermis of the skin. It produces bones, including the clavicle, which is right here, also known as the collarbone, and facial and cranial bones, which are drawn here in the skull. Okay, and the first step of intramembranous ossification is where an ossification center appears in the middle of the fibrous connective tissue. So this is the ossification center, the dashed lines. And the ossification center forms when mesenchymal or stem cells cluster up into the center like a little party. And stem cells are cells that undergo mitosis in order to produce daughter cells that will form into the osteoblasts, which are here. The mesenchymal cells then secrete organic compounds of the bone matrix. So these are the mesenchymal cells right here. And then these components will turn into osteoids. So the mesenchymal cells will secrete into here and turn into the osteoids. And then during this calcification of the mesenchymal cells will differentiate into osteoblasts, and then hence the name ossification. They will go into the ossification center. So like I mentioned before, these are the mesenchymal cells. They will undergo calcification and turn into the osteoblasts. Okay, the second step of intramembranous ossification is where a bone matrix called an osteoid, like mentioned in the previous picture, is then secreted within the fibrous membrane. And then the osteoid is then secreted by the osteoblasts and mineralized by calcium salts through a process called calcification into the fibrous membrane. And during calcification, an enzyme called alkaline phosphatase plays a huge role in this process as well. And then next, the osteoblasts will become trapped into the lacunae and turn into osteocytes. So here's these are the osteoblasts, and then they get trapped into the lacunae and turn into osteocytes. Okay, here is the third step. As the bone develops, the osteoblasts need many nutrients and oxygen in order to develop. And then the blood vessels here help aid into the bone development and supports that need. And then the bone of the periosteum will form in this process, or this step. And when an osteoid is between the embryonic blood vessels, a random network made from trabeculae forms. And trabeculae are spicules that form a network in cancellous or spongy bone. And then next, spicules begin to connect and begin to trap the blood vessels. And then the mesenchyme begins to condense. So these are the mesenchyme on the outside. And then the mesenchyme will then form the periosteum of the bone. And the periosteum is located on the outside of the bone. And it covers, like I said, it covers the outer surface of the bone and just protects it, but it does not cover joints. Okay, and here is the fourth and final step of this process. And during this step, compact bone will then form and red bone marrow will then appear. But before this occurs, the bone starts as spongy bone. So these are the spongy bone in the middle, and then after more remodeling occurs during the process, the osteons will then be made and trap the blood vessels. And these osteons will join together and become compact bone. Yay! And this occurs on the outside of the bone. Compact bone serves as a protectant for the medullary cavity, and the medullary cavity contains the blood vessels and bone marrow, so that is very important. And then as bone remodeling begins to slow down, the mesenchymal cells form, and they form a fibrous periosteum, so that's this right here on the outside of the bone.